Hello guys, back with another calculus problem. Today we have an equation. Um, the equation is basically showing the voltage at a certain point on a circular disk. It's quite irrelevant what it is because all we need to focus on is the fact that how do we get the first derivative of this equation. And notice over here, it says it wants the first derivative um, with respect to r, but it wants us to replace the r, wherever we see r, with a over 7, a divided by 7. So what does that mean? Well, that means that after we differentiate the original equation, wherever we see an r, we replace it with this value, a over 7. So two ways to denote this. First way is, we want the derivative of the equation with respect to r. Okay, so the second way to denote this equation, or rather the derivative, would be dv, dr. So they are saying the same thing. This one is saying taking the derivative of the equation v with respect to r. And this one is also saying the same thing, so taking the first derivative with respect to r. And then I'm going to be using one more notation, which is going to be ddr. So this one over here, I'm going to take another color. This one over here is telling you what it is, like what the derivative result is. And this one is saying what we're going to do. So when I write this, that means that I am going to take the derivative of a certain thing with respect to r. Like, for example, if there's an equation, let's say r squared plus, I don't know, 2r. If I take the derivative of this, then I would write this notation right before it. But my result, if I take the derivative of this equation v equaling something with respect to r, then this is what I'm doing. I hope that makes sense. The concept confused me a little at first, but hopefully it makes sense to you guys. Okay, so let's start with the problem then. Okay, so let's rewrite the equation in my way. Let's see if that helps us at all. So I would say this is basically saying k times a squared minus r squared, and let's put that in parentheses, to the power of half. So that's the same thing as square root, just a different notation. It's easier to take the derivative this way, minus r. Okay, so notice we are taking the derivative with respect to r. So wherever we see r, we need to start differentiating. Okay, now we're ready to take the derivative. So I'm going to write that from here, that we are getting ready to take the derivative of Vr, and it would equal, so k does not have any r in it, so we are just going to leave it as it is. It's a constant, times, then we do have an expression which is a squared minus r squared, so that does have an r in it, so we are going to take the derivative. So this is just saying that we are going to take the derivative of this expression with respect to r to the power of half, minus, hey, we see another r, so we need to take the derivative of this as well. So we are getting prepared to take the derivative of r as well. Okay, let's come a bit lower. All right, so let's do it step by step. K is just not to be touched because it doesn't have any r in it. I'm going to go to another page. I'm going to take the derivative of this expression solely, just to show you how we would do it. So I'm going to come a bit over here. Okay, so the derivative that we are trying to take is ddr, and the expression is a squared minus r squared to the power of half. Okay, so this needs this will need chain rule to be applied to it. So what we will need to do is that we will need to use this formula. So f prime g times g prime. So we need to allocate f and g to this expression. So I would say that the expression is basically x to the power of half and a squared minus r squared. So if I were to allocate f to x and g to a squared, so then I would come and take the derivative of it. So I would say dr. So the derivative of x to the power of 1/2. Sorry, I kept saying x squared. It's x to the power of 1/2 would be half. So we bring the power down next to x to the power of negative 1/2. So what I did there is that I took 1/2 and I minused it by 2/2, which is 1, and that resulted in 1/2. Okay, but then the rule is telling us, hey, after you take the derivative of f, which we just did, you need to put the g function inside it. So instead of x over here, when I remove the x, we should write the original g function. So I'm going to just put a parenthesis next to it like that. And I'm going to put a squared minus r squared. And I'm also going to be moving this power just up here so that it's more clear, like that. Okay, but we're not done yet. Now we need to take the derivative of g, which is this one. And that would be 2a times minus 2r. And one thing we need to notice is that, yes, the derivative is technically this, but this is a constant. A is a constant. We are trying to take the derivative with respect to r. So how I want you to think about r is that a constant is just any number that you, for example, if you were to say a equals 3, okay? So the original equation had a squared in it, and if you were to take the derivative of a squared, that would be 2a. So it would be 2a, right? But then if you were to plug 3 into it, so if you were to say 2 times 3, that would be 6. The derivative of 6 is just 0. So the derivative of a constant is just 0. So here we just have a 0. Okay, great. Now that we have found out the derivative of a squared minus r squared, we can rewrite it as the found value. So equals k times, so what we got was half times a squared minus r squared to the power of negative half times negative 2r minus, and now we have that dr r, which actually the derivative of r, so r is to the power of 1. So if you bring 1 down, and then the power of r will be 0, and r to the power of 0 is just 1. So 1 times 1 is 1. So the derivative of r is just 1. So we can just go ahead and write this as minus 1. Just take the derivative already. Okay, great. Now I would say that when I manipulated the equation, when I took the square root out, it helped us a lot to get the derivative. But now I would like to put it back into a more comprehensible form so that I can simplify it further. So now that we have the full derivative, I'm going to leave k as it is. So 1/2 can just go under k as 2. And since a squared minus r squared is to the power of negative half, so when something is to the power of half, it's just a square root. So let's write the square root, and then let's write the stuff under the square root. And the reason why it's coming underneath k is because it's negative half. So when it comes underneath the fraction, then it may have a positive property on its power. Then times negative 2r, so we can just put negative 2r over here, and minus 1. And then notice we could actually cancel this 2 with this 2, and then rewrite even a more simplified version, times negative r over square root of a squared minus r squared minus 1. And now all is left to do is to replace a. Okay, so quickly referring back to the question, we can see that the question is asking us to replace the r value with a over 7. So let's do that. So now that we have found a differentiated formula, we could rewrite this as, so the derivative a over 7, and this just means that everywhere we see r, we must replace it with a over 7. So this would be k times negative a over 7 divided by root of a squared minus, again, r, so we must replace this by a over 7 and to the power of 2 because it's r to the power of 2, and minus 1. And then we must simplify this. So I would start by simplifying this part first. So a squared minus a over 7 times a over 7 would be a squared to the power divided by 1 minus a squared over 49, equaling the common denominator, which is 49, and denominator 49 times a squared minus a squared, resulting in 48 a squared over 49. Okay, brilliant. So now we can write it again as, we could write negative k times a over 7 divided by square root of 48 over 49 a squared minus 1. So this could still be simplified further. So if we actually take this square root into action, so if I'm just gonna draw this border so that I'm gonna just say that we're gonna focus on this part. So if we, so the square root of 48, let's just leave it at that. But the square root of a, so a squared underneath the square root would just give you an a. Then 49 underneath the square root would give you 7. So we could rewrite this as 48 times a over 7, like that. So we could rewrite the fraction like that. Okay, so we could then rewrite the whole equation in a very simplified manner. So equals negative k times a over 7. Now times, now we're going to bring this fraction up, and when you're dividing two fractions, you can take the second fraction and take its reciprocal, so flip it. So put the 7 up, flip the places of denominator and denominator. So 7 over root 48 times a minus 1. And now if you picked up, we could cancel the 7s and the a's. And finally, we are left with the most simplified form, I believe. Negative k over root 48 minus 1. And this is just for the savvy math people. If you're really savvy, of course, you could, it's not required, I believe, but you could make it even more simplified and simplify the root as 4 over root square, over square root of 3 minus 1, which this is by definition more simplified than this one, but really by a very small margin.